because of the mechanical demands being made of sheet metal screws, especially the self-drilling screws, there's a tremendous amount of stress or force on those when we're using a power driver to install them. So you'll find that they're most typically made out of a harder material than you find used in wood screws. So stainless steel being the most common steel alloy that's used, but you will also find, in some cases, hardened steel, where there is not a lot of concern about oxidation, or aluminum, where it's important that there be a compatibility between the fastener and the material that it's being used to secure. This is opening a whole other can of worms, but know and understand that not all metals are compatible with each other, and some metals will readily corrode each other if they're in physical contact with each other under damp conditions. The example that most readily comes to mind is in plumbing, where you don't want to have iron pipe and copper pipe in contact with each other, or in the case of castings. If you have an armature or structure in the castings, you would never want to have a steel structure inside of a casting, because it can result in the corrosion of the bronze that you're casting around it. So typically a stainless steel structure would be used in its place to address that concern about them corroding each other. So another type of treatment that's given to fasteners are coatings that you find on the surface, and these coatings can be plastic coatings or epoxy coatings, and these are most typically used for either color matching the sheet metal that you're installing, or again, they do have some capacity for minimizing oxidation. Okay, in this setup, we're going to attach leather to square tubing. Again, this is nominally a 1/16 of an inch or 16 gauge square tubing, much in the way that I made the attachment of this hinge onto the square tubing. And remember, it's important that we minimize the length of those fasteners because, well, typically shorter fasteners cost less, but more importantly, we want to make sure that we don't have an excess amount projecting into the inside of our volume, if that's important. But again, this is typically used when we're not seeing the inside or where access to the inside is closed. So in this setup where I'm attaching the leather to that square tubing, I went ahead and pre-punched a hole in that leather so that as I'm using that self-drilling bit to go through the metal, it's not grabbing and pulling that leather and moving it around. I also went ahead and center punched through that hole, because just like a drill bit needs a center punch, a self-drilling screw also needs a center punch as a point of reference to follow. So we're going to do that. We're also going to take a look at making an attachment of felt to this piece of copper, and I've got it held down with a piece of wood to hold that securely in place. And clamping is highly underrated. Whenever you're drilling and driving metal fasteners, it really is hugely advantageous to have two hands on the tool, especially because it does require a tremendous amount of downward force to get those self-drilling to drill a hole and cut the threads and fasten or secure the material together. But it's not just the fact that we require a lot of force, it's that we need a lot of good, steady downward force at the beginning of the process as we're drilling, then a little less force as we start to cut the threads, and very minimal force as we finish the securing the material in place, because if we were being too aggressive, it might tear through that material. So one of the things that's going to give us an advantage to minimize the prospect of it tearing through that material is to use washers. And in this case, I'm using what's called a finish washer or a donut washer. And finish washers or donut washers are sized for particular screws. So I've got a panhead, Phillips drive, self-drilling, self-tapping screw. I've got the correct Phillips driver bit installed in my cordless drill, and I'm going to go ahead and set that tool up so that it is set for driving, and it's set at what is going to be right now my best guess at what's going to be the appropriate setting. But again, it's always good to do test in advance, and better to err on the side of caution and have it not sink the fastener down to where you want it than it is to have it set too high and have it strip the threads out or tear through the material that you're trying to secure. So, fasteners in place, oriented into my hole, good steady downward pressure. It's cutting, and now I snug it into place. Let's take a look at going through a piece of copper with the same type of fastener. Oh, wait, let's try something different. Let's take on this hex-headed fastener with a flange. So I'm going to swap out my drivers, secure it in place. My magnetic bit holder will hold my self-drilling, self-tapping screw in place. Bring the clutch down to a lower setting. I've already center punched into position. And there we have it. Now, in order to ensure that I wasn't drilling into the wood as well, I went ahead and created a pocket underneath that in advance of drilling so that, well, it looks like I might have missed my pocket by a little bit. Let's see. Well, okay, so first you don't succeed, try again. So I'm going to back this off just a hair. Well, you see I was off by just a little bit. I just missed my hole. So ain't no big thing, because once I've got that position secured, now I can go ahead and just go to drive this with a hand nut driver and finish that up. So tighten that down by hand. Threads bite in secure in place. And now my felt is firmly secured or bridging across the surface of that material. And I can come back in around and finish this other side. Put my blocking back into place. Let's move this center so we have a better view. Move my blocking back into place. Use the existing pocket hole for that first fastener to get secured into. Center punch. I've got to swap out my driver here. trying to move this around just so you have a better view of what I'm doing here. And there we have it. So this is felt attached to a piece of 16 gauge copper. You can see that the donut washer is doing a great job at distributing that load over more area, so it's less prone to tear out, whereas this truss head was doing an okay job for holding that down into place without tearing through. But I can tell you that this is less tolerant of any kind of forces that are pulling against it than is the donut washer, or then would be something like this Philister head, which again is more effective at distributing load over more surface area.